So far, we learned about the three basic data structures, namely arrays, singly linked list, and doubly linked list. We learned about their operations and also their time performances. It's really important for you to make sure you understand them because they will be used as building blocks, basic building blocks for the more sophisticated data structures or algorithm. We'll see some of them which is not so sophisticated in this lecture, but definitely later when we see the trees or graphs, we definitely have to use them. Right, and before I talk about the data structure like stacks or queues, I would like to talk about the notion of abstract data types and also modularity. So these are very important software design concepts that you want to have whenever you design your software for your algorithm. Let's talk about the learning outcomes quickly. So you're going to learn about the notion about abstract data types or ADTs. And the obligation for ADT supplier, we're going to draw the notion, the difference between supplier versus clients, and also what would be their obligation for the supplier implementer, or also what would be the benefit for the client or the user. That's something we're going to clarify to see the context. And the criterion for modularity, and also what really is a modular design. And ADTs, and the ADTs that we're going to talk about in this lecture is rather not really sophisticated, but it's definitely in some way more sophisticated than the arrays linked list, because we're going to use them to build these two ADTs. We're going to talk about stacks and queues, and we're also going to talk about their application as well. Okay, and of course we're going to see how we can implement these two ADTs precisely in Java, and we're going to use interfaces. So I'm going to suggest right away about some background study. Again, the background study, it's in some ways optional. If you feel very confident about this background study which you learned from the earlier OOP course, then you can skip it. However, if you really don't feel solid about this background study over here, I would suggest you spend time catching up with this, right? They will appear in the later assessment. Okay. So it is assumed that you actually learned about interfaces. I would suggest take a look at these checklist questions. How do you declare an interface in Java? And also, how do you create a class implementing an interface, right? And also how the polymorphism and dynamic binding actually work when you have an interface. Let's say you have one interface on the top, you got two subclasses implementing this interface at the bottom, right? So how does the polymorphism and also dynamic binding actually work? It's really important for you to check. If you're not too sure about any of these three checklist questions, then I would suggest you actually review the background study. Right, so you can definitely go back to my earlier recording site for 2030, okay, and then go to week number 10, lecture number 6, and it will be parts B1 to B3. Yeah, that one actually talk about interfaces. You can definitely refer to it. You can also look at the slides just to catch up. That's okay. But if you really need some detail explanation, you can definitely look at the videos or reach out to me if you got any trouble understanding the idea. Right, so assuming that you know about the basics for interfaces, so we're going to show this week, I'm not too sure if I will get to it, but if not, definitely next week, we're going to see how we can implement a generic stack and also a generic queue using interfaces. Not only that, we're going to use generics, which you already reviewed, and also we're going to use the interfaces, both of these. Alrighty, let's now talk about abstract data types. Abstract data type is actually an idea that needs to be built up. So it's kind of difficult to really give a single definition right away. I need to give you all the contextual information. Let me start with this. So I want to draw your attention to the notions about contracts, client, and supplier, especially in the context of OOP. Let's now go over some bullet points, and then I'll visualize the contractual relationship between the client and the supplier. Right? You can think, just before we move on to the bullet points, think about the clients over here is more like a caller, right? And the supplier is more like a callee. So you should have already heard about the notion about caller versus callee back in your OOP course. But now we are trying to lift up the level to talk about something that's more related to software design. So that's why we say clients is supposed to call caller, and supplier is supposed to callee. Okay. Right, a supplier simply implements and provides a service. So if you think about a supplier can be like a callee. So whenever you have a callee, that means a method that's being called. So that method really provides some service. Maybe the service will be like sorting, or maybe, for example, let me use the microwave example, just more real life, right? Let's say the service we're providing is like a microwave, right? Which can heat up your lunchbox. And what about clients? Client is more like a caller. Caller simply calls another method that provides the service, right? So the client uses a service provided by some supplier, right? That makes sense. And let's now just go over this one together. So the client is required to follow certain instructions to really obtain the service. For example, if you want to use a microwave, it is assumed you as a client, you actually should, number 1, turn on the power, number 2, closes the door, and number 3, whatever you want to hit should not be explosive, right? If you violate any of these assumptions, that means somehow the contract you actually sign between the microwave manufacturer and also yourself has been broken. In order for you to really get some service as a client, you must make sure you follow all the instructions, all the assumptions. If the assumption is broken, that means the contract is broken. And if the instruction are really followed, then the client, if the instruction are actually followed, positive, in that case, you can expect that the service that you want is really guaranteed. For example, you want your lunchbox to be heated. Apparently, lunchbox is not explosive. And you close the door, turn on the power, and heat it, and it should be heated, right? And the client does not care about how the supplier implements it, right? Thinking the following scenario. Whenever you're using some Java library class, by importing it into your Java projects, you definitely don't have to know about the implementation detail for individual library method. For example, you might just simply import the ArrayList class into your projects. And if you call the add method from the ArrayList, do you need to know how the add method has been implemented? You don't need to. And do you really have to care that there might be some resizing strategy for the dynamic array that's behind the scene for the array list? No, you don't have to. As a client, you just use the method as required. That's really specified in the API page, right? And so far, we have done a very brief introduction to clients versus supplier, right? And so, can you actually summarize about what's really the benefits and also obligation for the two parties, for the client and the supplier? It's kind of symmetric, right? You can think about whatever that's really the benefit for the clients, it will be the obligation for the supplier. And whatever that will be the benefit for the supplier, it will be at the same time the obligation for the clients, right? It's kind of symmetric. How can you actually summarize this contractual relation between the two parties? Let's take a look at the table, okay? So we got benefits and obligation in one dimension, and let's now talk about, first of all, the clients. What would be the client's obligation versus benefits? What we learned about was the client must follow certain instructions. Once they have done that, they can expect that the service they want can be guaranteed, right? So that means the benefits they can really get is about obtaining a service, right? So as long as I fulfill my obligation, which is to follow the instruction. That's very straightforward conceptually. What about for the supplier? Well, it will be symmetric. Whatever that's really the benefits for the clients over here, let me try to highlight it properly. Whatever that would be the benefits for the clients over here is going to be at the same time the obligation for the supplier. And whatever that's the obligation for the clients is going to be the benefits for the supplier, right? What does that mean? That means the supplier, they can assume the instructions is actually followed. What does that mean? In this particular case, we assume that the client is going to turn on the power, closes the door, and also hit something that's not explosive. That means that's the benefits to the supplier, because the supplier, the manufacturer of the microwave, they don't really have to design and implement some very magic microwave, which can still heat up something that's explosive and something that can be heated up without turning on the power from the microwave, or something that can be heated up even with the door open, right? That's not something we are requiring the supplier to do. So the supplier can somehow make some certain assumption about what their client is going to follow when they use the microwave. So that's why I say it's the benefits for the supplier. Okay, over here. And what about the obligation for the supplier? Well, assuming that your clients actually follow the instruction. They actually fulfill their obligation. In that case, for you as a supplier, your obligation will be to make sure you really provide a service to heat up their lunchbox. All right. And so there's a contract. Let me summarize between the two parties. The contract will be violated if either of the following is going to happen. Either it could be the fault from the client side, or it could be the fault from the supplier side. What if the instruction is not really followed? Which side's fault is that? Well, it should be the client's fault, right? Because the client is actually assumed to actually follow all the instruction for the microwave usage. And what about the other kind of scenario where they could be the contract could be violated? In that case, if the instruction somehow is followed by the clients, but the service is not satisfactory, maybe I heat up the lunchbox, but somehow the lunchbox still remain cold or not hot enough. In that case, it would be the supplier's fault, right? Right. So this slide here really summarizes three important notions: clients, supplier, and also the contractual relation between client and supplier, using the microwave example, right? And so what we want to do now is we want to adapt this notion about client, supplier, and contracts into the context of object-oriented programming. Let's now do that.